So far we have looked at quadratic functions in the vertex form and in the standard form. And now we're going to look, and we explored a little bit in the factored form, but we're going to today explore in depth. It's called the factored form or the intercept form of the quadratic function. They're the same form. And when it's in the factored form or the intercept form, we're going to look in how to find the solutions and the axis of symmetry. So let's go ahead and just start out by looking at number 1. And number 1 gives us our quadratic function in the intercept form or in our fully factored form. And we want to find the zeros and the axis of symmetry. We already know how to find our solutions or our zeros. And what we do is we set each factor equal to 0. So if I set this factor, x plus 2 equals 0, and then I'll also set this factor, x minus 4 equals 0. And I'll solve each one of these for x to get my 2 zeros or my 2 solutions. So my 2 solutions to this quadratic function are x equals -2 and x equals +4. Now the other thing it wants us to find is the axis of symmetry. So what I want to do is just a quick little graph over here so that you can kind of think about what we already know. So if we know that our zeros are here at -2 and at +4, so it's going to look something kind of like that. And what we're looking for, what we want to find, is our axis of symmetry, the thing that cuts right down the middle of the vertex, or the parabola, goes right through our vertex, and everything on either side is exactly the same distance apart. So the same distance this way and the same distance the other way. So we're going to use the symmetry to help us find where the axis is. So we know that in between our 2 solutions, the very middle of these 2 solutions is our axis of symmetry. So we're just going to add up our 2 solutions and divide by 2 to get this number. That's what's happening. So we're going to say -2 plus 4 divided by 2. So -2 plus 4 is +2 divided by 2 equals 1. That's our axis of symmetry. Okay, so I know that my axis of symmetry is x equals 1. Now they gave us a formula. It's a very fancy and lovely formula that's basically saying P plus Q divided by 2 is my axis of symmetry. So I want you to look for a minute at this pattern, because what we've got here in our vertex or our intercept formula is we've got x minus p and x minus q. But when we look right here, I've got a plus and a minus. What is my p value in this case? Well, when I solved this and put it equal to 0, my solution was -2. And in this case, when I solved it, my solution was +4. So if I'm going to use this formula, P plus Q, kind of remember that saying, x lies. So that's going to be the opposite of your x's that we use in that formula. So the opposite of +2 is our -2. The opposite of -4 is our +4, giving us our axis of symmetry. Okay, I want you to pause the video and do number 2 on your own. Find the 2 solutions and the axis of symmetry, and then start it back up to check your answer. Okay, it was a very straightforward. Hopefully you got all the way to the 2 answers, the 2 solutions, and the axis of symmetry. Now on number 3 and on number 4, they didn't give us the equation in factored form or intercept form. So before we can find our two solutions, we need to fully factor each one of these by removing the greatest common factor and then seeing if there's anything more we can factor, and then setting our factors equal to 0 and finding our axis of symmetry. So I want you to do number 3 and number 4 on your own completely. Pause your video while you're doing it and then check back for the explanation. So when you were factoring out your greatest common factor on number 3, you were left with a difference of 2 perfect squares. So it's really x squared minus 1 squared. So I went ahead and broke them out. Broke out my 2 perfect squares. Set the factors equal to 0. So I had x equals 1 and x equals negative 1 as my two solutions. When I put that through my axis of symmetry, I had an answer exactly 1 over on either side of 0. So my axis of symmetry ended up being 0. And then on number 4, it was a very simple factoring problem. You guys have done a ton of them. I'm sure you were very good at it. Finding your factors for 20 were 4 and 5, so x plus 4 and x plus 5. When I added negative 4 and negative 5 together, I got negative 9 over 2. So my axis of symmetry was at negative 4.5. Okay, so last two we're going to do are number 5 and number 6. They're already in factored form, so I want you to go ahead and find the solutions. Fill out all the parts and pieces for number 5 and number 6. Pause your video while you're doing it and check back for the final answers. Okay, so on number 5, our intercepts were negative 5 and negative 1. Those are our zeros, also called our roots. Then put it through the axis of symmetry to find the middle, which was negative 3. Then I plugged in my x value of my vertex, which is what I got from the axis of symmetry. I plugged the negative 3 into my equation, and that told me my y value was negative 4. That was the other piece of the puzzle I needed to find my vertex. Domain, parabolas, always all real numbers because we can't boundary either the left or the right. And our range, we have a boundary here at negative 4. It's everything greater than or equal to negative 4. And then if we look at number 6, pretty much followed the same process. This one happened to be a maximum function. So just check and make sure you have all the correct answers.